I just threw the word out, magnitude, just a bit earlier. So, magnitude of the vector. I already mentioned the vector has both magnitude as well as direction. If I wrote the number 2, the magnitude of the number 2 is just 2, right? If that is the case, what is the magnitude of 2I vector? 2. Still 2. Now, how do we justify this? Well, I stress about understanding always why that is important to me. If you understand something, you don't have to memorize anything. Simple, just come to that. So, constant, one dimension, 2. If I asked you, what is the magnitude of that vector? You gave me the answer, 2. That pretty much is the length between 0 and 2. Good. So point A to point B, AB vector is what we have. Vector notation, 2I vector. The magnitude of AB is 2. That is nothing but the length of vector AB. I'll just write it as AB vector. Good. Now, what we know as length up there is also
magnitude.
okay, magnitude, also known as length, magnitude,
Distance.
distance, right? Distance. But we've got to be careful when we refer to it as distance, because when we talk about distance, just for a point, it is with respect to the origin. That is always our starting point, hence origin. If you are looking at a vector of length 2, perhaps right here, still a vector of length 2, but you're not starting from the origin. So you would refer to it as the distance between those 2 points. How do we find the distance?
B minus A. Or B minus A.
Is it that easy though?
The distance between what exactly?
In 2D space? Now, one-dimensional, I agree. Now, you're absolutely correct.
Oh, you want distance formula?
Okay, what does that change?
A squared plus B squared is equal to C squared. Or I mean, that's Pythagorean, that all works, you know.
Well, yeah, it all works. I mean, it all goes back to that one person.
I mean, it is, I mean, today's just triangles and so on.
I mean, and if you look at a good amount of mathematics, simply goes back to that guy. So, we're about to say something, Jake.
I'm just gonna say you keep the distance one, so you just take square root of x2 minus x1 squared, plus y to minus 5 2.
Distance between 2 points, going back to algebra. If I call the origin as x1, y1, and that as x2, y2. We know the distance formula. What is the distance formula? Square root of x2 minus x1 squared plus y2 minus y1 square. X2, you tell me, what is X2? 2. X1,
0,
0. Y2,
0,
Y1,
0.
square root of 4 plus or minus 2, length can't be negative. So 2. L is correct in one dimension, it's just b minus a. But it also applies in this map distance formula. What we know as length of vector is simply distance of a point from origin. You can also find the length between two vectors. We will address that in a second. So AB, now I will have that vector 0. 60. Good. So A. C. Starting point is A, ending point C. So I can write AC vector. Its magnitude is simply length of AC vector. Then magnitude of AC vector, which is the same as
Distance,
distance between
the origin and 6
point C, between A and C. In our case, A is the origin. Good. We can use the distance formula and come up with the magnitude. Agreed? Now, if I took this, say shifted it over here, will I get a different length? No, still the same length. So this is what I was mentioning earlier, that it always depends on the starting point. The starting point, you change the axis, it's relative to that. So you can move this way, that way, the length is going to be exactly the same. Good. Yet another reason as to why I vector, J vector, and K vector are important in practice. So that when I write something, J follows what I just wrote, and Chris follows what I just wrote. Do you follow what I just wrote? Yes, okay. The distance of that vector, 6, 2, you can write it as this. Good. So if the vector A is A1, comma A2, comma A3, and if I simply say this, looking at the standard system origin to the point A1, A2, A3, extended to 3 dimensions, I'm finding the magnitude of the vector A. What would that equal to if I'm in the standard system?
It's the same thing with an extra bit on the.
Yeah. Same thing with the extra thing added, right? So over here, I had x2 minus 0, correct? If all coordinates x1, y1, z1 are 0, we are simply looking at x2, y2, and z2, correct? So in 3 dimensions, imagine there is a point right there, and that is A1, A2, A3. Origin to that point in space. What is the formula? Well, distance formula, A1 minus 0 squared, A2 minus 0 squared. So the formula for magnitude of a vector, simply A1 squared, A2 squared, A3 squared. Good. Now, in terms of notation, I want to reiterate, you can write it as a pointer vector on top of it. You can use a bold notation and get rid of the arrow. So textbook uses that notation, get rid of the arrow, write it in bold. I hate using the arrow notation. That's just me. Okay. If I extend this idea, magnitude of a vector in n dimensions. Standard space origin is where I'm going to start. Magnitude is the same as length. If you're referring to the standard system, distance between 0 and, origin and the point. Started with 2 dimensions, 1 dimension, 2, 3. If I extended it to n dimensions, first question, how would I represent the vector A?
A sub 1, comma, A sub 2, comma, A sub 3, all the way up to n.
Good. If I did the magnitude, which is the length, distance from origin,
Square root of the sum of from n equals 1 to infinity to, no, I lied. And no, n equals 1 to n, or n equals, no.
Ellie?
I was gonna say, and
Okay, can we go from I equals 1 to n?
I equals 1 to n.
N of a sub I squared.
Good. Compact notation, if you want to stretch it. It's just this. Good. Representing distance, same magnitude.